Right, today we're going to look at in a bit more detail artificial satellites, or more specifically, the different orbits that they can have. And there's many hundreds of satellites in orbit around the Earth, but they all have different uses and they also have different orbits, and that's what we're going to look at today. So, first one I want to look at is called geostationary satellites. Now, what does geostationary mean? Well, it has geo and stationary in it. Geo means anything to do with the Earth. Stationary means in the same place. A geostationary satellite is one that's always over the same point above the Earth's surface. Okay, it doesn't appear to move. Now, how does it do that? Well, it's quite simple. It has an orbit time of exactly 24 hours, and it orbits in exactly the same direction that the Earth rotates. So we know that the Earth spins on its axis every 24 hours. So if the Earth is rotating every 24 hours and the satellite is orbiting every 24 hours, it will appear to be over the same point on the Earth's surface at all times. Now, what's the uses of that? The main one, or the most common one, is communications. Say, for example, you're here and you want to make a phone call here. Okay. Now, the microwaves from your phone are not going to travel all the way around in the Earth's atmosphere, so you have to bounce them off a satellite like that. Now, that's only going to work if the satellite is in the same place at all times, because you need to aim the microwaves at the satellite for them to be retransmitted back to Earth. Okay. So geostationary satellites, that's where the satellite is over the same point at all times because it's orbiting in the same direction and with the same orbit time that the Earth rotates at. Okay, so there's your first one, geostationary satellites. So what other orbits are there? Okay, we have polar orbits. Now these are much closer to Earth. They're a lower altitude. So as a result, the satellites move much more quickly. Okay, they have much shorter distance to cover than your geostationaries. Okay, and also the centripetal force, the Earth's gravitational pull is much stronger, so they're going to travel much more quickly. Geostationary satellites have to be very far out. They are high Earth orbits. They all have to orbit at a very high altitude. We'll find out in a minute how much. Okay, but polar orbits are very close. Now, if you've got an orbit, polar orbits can have an orbit time of about 2 hours. So every 2 hours they're going to go around the Earth. But at the same time, the Earth is rotating. So this polar orbit is going to cover a different part of the Earth every orbit. So in time, it gets to cover every part of the Earth's surface. Now, the most common use of a polar orbit would be Google Earth. We know that Google Earth is a satellite or a system of satellites that is constantly orbiting the Earth, taking up-to-date photographs of every part of the Earth's surface. Okay, so there's your polar orbit, there's your geostationary. Now, there's just a couple more. There's one. I mean, so some satellites can have what are known as elliptical orbits. Instead of these two are both circular orbits. Both your polar and your geostationary are perfect circles. However, you can have a satellite orbiting in an elliptical orbit like that, okay, where it's very close and moves quickly, but then it'll go quite far out and move slowly. Not unlike a comet when it orbits the sun. Okay. Now, one use for this is when this satellite is at this point, it's moving more slowly. So it's again, communications will be a good one. So it's going to be in over the same region of the Earth's surface for quite a long time. Okay, so a communications satellite would have an orbit like that. And finally, there's one last type of orbit called the Sun synchronous orbit. Now, that's an orbit that has just the right inclination where the satellite is constantly in sunlight. Okay, as the Earth orbits the sun, okay, this orbit is arranged so that it's constantly in the sun's light. Now, a very good use of that is it means that the satellite solar panels can be constantly absorbing sunlight and recharging the batteries on the satellite. Okay, so that would be a satellite that has a very, very high power consumption. Okay, so there you have it. There's just a few examples of different orbits with different satellites. Now, I've got a little starter for you. It's a little calculation. Like I said, geostationary satellites are ones that they have a very, very, very high altitude. Now, these have to orbit at this distance, 42,000 kilometers from the center of the Earth. That's quite high. Okay, not many satellites orbit further than that. All right. Now, if that's their distance near surface, okay, how fast are these satellites orbiting relative to Earth? Okay, there's a Google Doc for you to have a look at. There's a couple of hints on there, but I want you to do that little calculation as a starter. And then I've got another worksheet for you to do as well. Okay, thank you very much.